Hello everyone, I'm Shibo from Carnegie Mellon University. Today I'd like to introduce SuperMap, a spatial-temporal line system for visual language navigation. Real robots operate in challenging environments and must know not only what is here, but what was here before, what has moved, and what has disappeared. Map describes the world, memory captures how it evolves. In this work, we present an initial attempt at incorporating such memory. Not memory in the full cognitive sense, but a first step towards retaining the past authorization to enable real-time map updates. Many communities have tackled these problems. Object detections give accurate 3D bounding box, but the lack of long-term identity tracking. Scene graphs model object relations, but they are typically static. Semantic mapping provides rich semantics, but is usually offline. Semantic slams localize robustly, but lacks of persistent scene understanding. Each solves the one piece, but none builds the persistent word memory. Our key insight is that building persistent word memory can follow three simple design principles. First, reliable geometry. Stable localization provides the spatial foundation for associating the observations over time. Second, persistent identity. Robots should recognize the same objects across time rather than rediscovering it in every frame. Finally, memory-driven scene graph. Memory is not the end goal. It exists to support downstream tasks such as visual language navigation. SuperMap is one realization of the three simple designs. Let's begin with geometry. Traditionally, SLAM has focused on estimating the robot pose. We argue that the geometry serves a much broader role. It provides a stable spatial foundation for persistent object memory. By combining the geometric consistency with the semantic consistency, SuperMaps not only recognize the correct object categories, but also preserve the same object identities over time. This allows us to build accurate and persistent 3D object detections, even during these long-term operations. Once geometry is reliable, the next challenge is identity. Robots shouldn't simply detect a trash can, they should remember which trash can they are looking at. SuperMap maintains persistent object identities across viewpoint changes and robot motion. As the video shows, it continuously tracks both dynamic object and long-term scene changes, preserve the same object identities even as objects appear, disappear, or move. This is what transforms object detection into persistent word memory. Our final principle is memory-driven navigation. Once the robots remember the word, they can reason about it. SuperMap builds a persistent 3D scene graph that captures both object relationship and scene histories. On the left, robots receive the instructions. Go to the whiteboard next to the painting. Although there are four visually identical whiteboards, it identifies the correct one by reasoning over spatial relationship in the scene graph. This example demonstrates how persistent word memory transforms perception into actionable knowledge for visual language navigation. Finally, I want to emphasize that SuperMap is not tied to any specific detector. Its decoupled memory infrastructure as better perception models emerge, whether grounding Dano, Boxer, or future foundation model, they can plug into the same memory layer without redesigning the system. This persistent memory can support navigation, automatic dataset labeling, and more.